In today's video, I'm going to demonstrate how to calibrate a point probe on a MicroScribe using the MUS software that comes with your system. First, a few things to note. You'll see that I have the SPAT spreadsheet as our background. We're not going to use that as part of the calibration, but I will show you how to use it to validate your probe once you have done a calibration. So to start, here in MUS, you'll want to select the probe icon in order to bring up the calibration wizard. There are several options there. Use the default probe, which would be the same as your master or working probe for your particular device. Use fixed Z offset. This would actually allow you to just place an alternate length for a probe. Don't really suggest using that, it's difficult. But what we'll be doing today will be to use the custom probe calibration process. And to start that, you would actually just select the radio button and you'll see that the screen has changed. Now, the MicroScribe software saves up to 4 calibrations at a time on your system registry. That means that you'll be able to come back to these probes on this particular computer that you're using, on which you calibrated the software. It does not carry with the device to other machines, so you'll have to recalibrate on another machine if you want to use the MicroScribe there. But there are 4 places to save this, as I've said, and you can choose any one of them. You can choose a specific name for them. Now, if there had been a previous calibration, just choosing from this list would allow you to change your probes, say done, and you're finished. But we're going to want to define or overwrite a probe, so we'll select this box. Now, the first step is to give this a different name, if you so wish. So let's just call it point, because that is what we're calibrating. Now, the second step is to place the device in the home position with the default probe. That's also another name for the master probe. Now, the master probe will have a red dot, as you can see in this example. You want to save your master probe and not use that for work because you'll wind up potentially damaging it over time. This means that you've always got a good reference probe that ties back to the original calibration of the device. So we're going to start by putting that on the MicroScribe. Okay. We're also going to use the tip tool or some other small Allen wrench or whatever you have in hand to make it a little bit snug. You don't want to over tighten that. Now, to get the MicroScribe into the home position, first of all, we're going to make sure that the ball seats really well down in the cup. We want to make sure there's no debris down in there that might be keeping it from seating properly. And you also want to make sure that the counterweight is solidly up against the base of the rest. So that's part of the home position. The final would be to for a MicroScribe I or a MicroScribe M, to turn it completely, counterclockwise. There's a little magnet that holds it in place. For the MicroScribe G, it's a little bit more arbitrary. You would just set the device sort of in the parallel, upright parallel to the front of the base. It's not as accurate for that placement for G as it is for the other arms. Anyway, we'll put this back around in its home position for MicroScribe I. Now at this point, we are ready to proceed. But before I do that, I also want to mention that there are a couple of kinds of point probes that we supply. One of them is a 60-degree point probe, and it looks like, this. And then there's also a very fine point probe, which looks like this. Both have M4 threads, so they'll work with the I or the M. There are variations that'll work with the G arms. So you want to make sure that you have your selected point probe ready to place on the MicroScribe in the next step. So now that we have the MicroScribe in the home position, the correct probe on it, the master probe on it, we're going to select the done right next to where it says place in home position with default probe. Now during that step, the device was automatically homed by the software, so you don't have to worry about doing that. Matter of fact, you don't want to home it yourself because you could interrupt the process. Now that we're going to come back and take off the master probe, and let's put on the point probe that we have selected to use. Again, place the arm in the home position, making sure it's properly positioned all the way around until it stops. And now then we can say we're done with that step. Now then we progress to taking point data with this point probe so that we can get good calibration numbers for it. Now, the thing about a point probe is that we can't use any of the divots on our calibration fixture. What happens is as we're moving the probe around, we'll literally be pulling its point up out of the divot, and that means that we're not getting data around a specific point. So you'll want to use the top of your calibration fixture, which is admittedly kind of slick. You're going to have to practice to make sure that you can actually hold that tip in one place and not let it slide while you're doing the process of taking 20 points. There are a couple of techniques that I use to achieve this. Now, first of all, you don't have to hold the point very tightly. And I also will say that some of these fixtures do not have the black PVC dot on top. That doesn't matter. Aluminum is soft enough that the point will kind of hold in place anyway. So there are two styles of taking this data. One might be easier for you than the other. One is to just use a circular motion. We're going to capture 20 points moving around like this. And then we'll come back with a little less angle on the probe until we get 20 points. Another is to use a defined pattern, sort of like an asterisk on a keyboard, where you imagine up and down, left and right, and then on diagonals taking 5 points. So we would do 1, 2, 3, 4, 5, then come over to the side, and then go 1, 2, 3, 4, 5, and then pick one of the diagonals. 1, 2, 3, 4, 5. Notice I have to twist as I go along. 1, 2, 3, 4, 5. Okay. Now I'm not taking any data yet, so we'll come back and do that. But I do want to point out there are a couple of things you need to be aware of. In addition to the slipping, there's something called the singularity position, which, as you can see right here, where I have the stylus in the same line as the tube right below, above it, the part of the arm right above it. You do not ever want to take data while you're in this position. And the reason is that the arm isn't bending freely at that point, so it's possible to put a torque and torsion on the system, which will disrupt your data. You always want to make sure that there's a little bit of a bend. So as I'm moving over from front of the joint to the back of the joint, I'll skip that area and then get back down to here before I take my next point. So let's go ahead and use this technique and take some data and see the results that we get. So again, I've picked the vertical direction first. So we're going to go 1, 2, 3, 4, 5. Now I'm going to do a horizontal, which means I pull the arm up towards me and then lean over to one side, keeping that bend. So 1, 2, 3, 4, 5. Okay. Now I'm picking a diagonal. 1, 2, 3, 4, 5. Notice how I'm twisting the arm as I go. 1, 2, 3, 4, 5. Okay. So having done that, we've got 20 points, and the blue bar is completely filled up. No error has popped up, so we got good data. And we can see some kind of result. So this tip, it's X and Y offset and the difference in the length of it from the previous tip. This is some of the information that's stored. Now to save this and move forward, we're going to choose Save Custom Probe Definition. You have to do this step in order to save your calibration. So let's save that. Goes back to this screen. It now shows that we've got a point selected. It is the probe that's going to be used. And we can say OK. And then let's come back here and do some test data. Now I'm going to start by clearing out the data that I collected earlier when I was testing the system to make sure it works. Okay. So in the SPAT spreadsheet, this is something that comes with current microscribes being sold. If you don't have it, you can download it from our website. I filled in a little bit of information about this particular device. The important thing is that I chose the model of the arm, which is 5DOF-IL. And the reason is that down here on the specification, it'll actually tell me what its advertised accuracy is. And we're going to wind up comparing to that value. As we put information in this field, though, these numbers over here can change, so we want to make sure that, make note of that ahead of time. So I've selected the upper left corner in this field. I'm going to go ahead and take some data, and I'm going to use the same technique that I used to calibrate it. I'm going to take a few points across and a few points up. Now we're only taking 10 points this time, so it's a little bit shorter and easier. 1, 2, 3, 4, 5. And I'll start back here. 1, 2, 3, 4, 5. And now we have a result. So the calibration, you're looking at 10 points. We were getting an average of plus or minus 4 thousandths and some change, which is below the specification of the device, which means we've got a very good calibration. So I would feel very comfortable using this probe to capture data with. Now I thought I'd go ahead and do the calibration again. This time I'm going to use the other technique, the spiral technique. So I'm going to start by going back to the master probe. So I'm going to take this point off. I'm going to put our master probe back on. Put the device into home position. Go ahead and call back up the probe calibration function. It's already set to use this custom probe, but what we're going to do is, overwrite. So again, define overwrite. It's actually telling us to put the currently installed probe or exchange it with the default probe as preparation for this. So we're going to say OK. I've actually already done that. I'm going to leave our new value in the field that we labeled point. Device is in the home position, so I'm going to say done. Now I'm going to put that point probe back on. Back into the home position. Now I can say done, and I'm ready to collect points again. This time we're going to use a series of circular sweeps. So I've picked a position for the probe. I'm actually testing the arm to make sure it feels limp, and I've got a good feeling for where that probe is positioned and that it won't move. So now I'll pick a point around the circuit I'm going to go. And 1, 2, 3, 4, 5, 6, 7, come up a bit. 8, 9, 10, 11, 12, 13, up a little bit more, 14, 15, 16, 17, 18, 19, 20. Now I didn't note the offsets that we had before, but these numbers look a little bit larger, which means this might have been a little bit sloppier. But we're talking in the 10,000ths range, so that's actually still, small numbers. I'm going to save, as we did before. I'm going to say OK. Now then, let's come back and do another try at the spreadsheet to see what kind of values we get this time. Again, we're going to take 10 points. I'm going to use the same technique that I used to calibrate the probe. Just fewer points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And as I look, we actually got a number that was quite a bit better. So, in any event, this demonstrates how easy it is to calibrate a probe using MUS. The key things to remember when calibrating a point probe is that this point is hard to keep from sliding around as you're taking the data. So you have to be real careful with keeping it in place. You see how, just playing around here, I can easily kind of move it. But once you get a spot, move the point around, the stylus around on that point a few times to kind of get comfortable with it being in that one spot, and then commence with your data collection. If it should slip at all, you are going to have to start over. But with a little practice, it's actually not hard at all to calibrate a point probe. I will say, though, that in general, point probes are going to be a little bit less accurate than a ball probe. And that's one reason a lot of folks will use ball probes. But there are situations where you don't want to have to deal with offsetting of the data. So we do make these very sturdy and very easy to use 60-degree point probes. And for those of you that really want to get down into some very fine work, these very small point probes have quite hard tips, and they will dig into just about anything quite easily. So using them, you're likely to scratch paint or metal surfaces. It'll easily put a mark on the aluminum. But anyway, I hope this video was useful. As always, if you have questions, feel free to get up with us, and we will do our best to make sure that we solve your problems. Thanks again.